Hey, did you know that you can look at the texture of an image? That's right, you can figure out how an image feels. See that dog? Dog's probably fluffy. You can know that from just some linear algebra. It's fun. Alright, so how do we do that? We're going to utilize something called a gray level co-occurrence matrix. And what that is like a two-dimensional histogram of pixel intensity color relations. Make sense? No, of course it doesn't, but that's fine. We're going to see how to implement it, and you can worry about the theory behind it later. Alright, so first thing we do is we take our image and we look at every individual pixel of it as a matrix. We're just gonna make up our matrix in this point and throw in some random numbers to give us some faux intensity values. Alright, so let's just put these in. In a real implementation, these would be a lot more significant, ranging from 0 to 256, or if you're on grayscale, from 0 to 1, but here we're just throwing in some numbers. Alright, so let's look at cases where one number is followed by another, and we're going to use that to generate our GLCM. And the limits of our GLCM are going to be our maximum intensity of our pixels. In this case, our maximum intensity is 5, so we're going to make a 5 by 5 square matrix. Alright, let's go ahead and look for some relations. Let's first look at when 3 is followed by 2. There are two instances where that happens, so we go down 1, 2, 3, and we go over 0, 1, 2. Alright, and since there are two cases, we put a 2 in the 3, 2 cell of our GLCM. Let's look at another thing. Let's look at when 1 is followed by 5. Alright, we go 0, 1, over 1, 2, 0, 1, 2, 3, 4, 5. Alright, so in the 1, 5 cell, we have one instance, and that gives us our representation. That's how it's kind of similar to a histogram, is that we get the spread of the correlations. Alright, so let's look at another example, GLCM, that we're going to refer to as U. We're not really going to pay attention to what values are in it, just for this example. However, we are going to throw in some fake diagonal values, in this case 1, 3, 5, and 9. Alright, let's look at a feature. Let's take the trace. The trace is when you sum the diagonals of a matrix. In this case, we would write that as the summation of U sub I sub I. Alright, and that would be the sum of 1 plus 3 plus 5 plus 9. And that would equal 18. So that's what we refer to as a Harlech feature. And there are tons of different Harlech features. And basically what you do is you calculate all these and you can compare them between different images, and you can find similarity and differences between images. It's a very common practice in image analysis, just feature comparison. You can compare entropy, energy, correlation. These are all Harlech features. But yeah, that's all for now. Thanks, and bye-bye.